Hello, everyone. Welcome. We're going to give a few minutes. Hey, Gennaro, how are you?
Hi, everybody. Good afternoon.
You've got your shirt on. Awesome.
I'm wearing the official DVC merchandise, so I get extra points in here.
Yes, totally. Lots of extra
I need to get something quickly.
Okay. Hey, Julie. Who do we have here? Do we have some new people that like to introduce themselves?
Hi. Hello.
Hi, Jose.
I
Hey,
didn't know
Mark.
we were doing merchandise.
He's got his DV. Perfect. Oh, I forgot my DV.
Hey everyone, I'm Santiago. I'm giving a talk today. Hey Danielle.
Hi, Danielle. Cool. Hey, Dimitri.
Hello. João's here. Hi, João.
Hello, how's it going?
Very well, very well.
Okay. And
Hello.
Hello.
Hi, Tapa. I cannot recognize your name.
Oh, okay. Let me actually try to change the name. I think that's possible.
Total data science.
Exactly.
okay.
Today is actually the DVC t-shirt day. It looks like Casper is also wearing one.
Oh, yes, indeed. Advertising, indeed.
And has a DV. Nice.
Oh, yes. Yep.
Yeah,
DV in
you
the corner.
did get your DV. I've been meaning to ask you.
I see that. It's like
It arrived in the post half open, and the postman had this really dopey expression on his face. When he Great.
Well, I think let's get started. And I'll admit people as they come in, but welcome to the July office hours meetup. We'll get started today, and we have two presentations for you. First up is João Santiago, who graciously goes by Santiago for ease of pronunciation. He has created dvthis to work with DVC while using our scripts. Santiago has been a contributor to DVC, and we are excited to have him here today to share his great creation and about his workflows at Billy.io. And so with that, the floor is yours. It's all for you. Go ahead, Santiago.
I'm going to talk about, like Jenny said, workflows with DVC, mostly from an R perspective, but some of the things that I am talking about can be applied to any language, really. It's just that R is my favorite data science language, and that's where I am applying this. And also, I'm talking about the dvthis, which is this package that I created to enable this sort of workflow more easily. Well, just a few words about myself. I'm originally from Portugal. That's why my first name has this strange squiggly line, and it's unpronounceable to most people. Although I'm now living in Berlin, where I'm working as a data scientist in this cool company called Billy, more specifically in the anti-fraud unit. And so if this was a live on-site meetup, this is kind of like how you would see me from your chairs, minus the blonde hair. Billy is a really cool company. We are a fintech from Berlin. We are around 120 people. Our two main products are giving liquidity or short finance to small and medium enterprises. And we have another product, which is a sort of buy now, pay later for business-to-business online shops. It's kind of like Klarna for companies. And it's in this second product that the R model that I will be talking about and the DVC pipeline is deployed. So it's a real-time product. You are in a checkout of an online shop, you click buy, and you need to get a response within a couple of milliseconds to a couple of seconds. In terms of team, we are 6 data scientists, 3 data analysts, and 1 data engineer. So we're not a very big team. And this is also a reason why down the line we chose DVC to work with in comparison to some other options. And we use both R and Python, depending on the use case, with a couple of other languages sprinkled in when they are necessary. But so let's talk about how we came to work with DVC. It all started, as most great journeys do, with a meme created by our very own Gennaro, who's also in this in the meetup today. And Gennaro had a very interesting problem. So Gennaro said, I want to save my amazing model, and I want to track the versions, and I want to track the data we use to train that model with, which if you are in this meetup, you probably know what you're talking about. And it was very frustrating to do this with the solutions that were available. And we thought, even though not everyone in the team had that specific problem at that specific point in time, we realized we will probably have that at some point. So we might as well look now for solutions. And so we drew up a table and figured out some options to deal with this. And we looked at Git LFS, and based on the trauma that Gennaro had working with this by itself, we said, no, the bandwidth is too low for the amount of data that we need. So it was insta-rejected. Then we thought, should we create our own solution with S3? Because S3 also has some cool versioning capabilities, and you can even have time to live, so you can clear out all data and stuff. But we are a small team. We would rather spend time doing models and analytics. So we said, this is too much work. So we also didn't do it. And then we looked at MLflow, which seems to hit most boxes, but at the same time, I didn't like it so much because I thought this is very prescriptive. It forces you to work in a very specific way. And at least at the time, it seemed to be very Python specific, which meant that I wouldn't be able to use it on my cool R stuff. And then I would have to come up with another solution, which is not ideal in a small team. And so, as you guessed it, because I'm talking in this meetup today, we went with DVC, which ticked all the boxes, allowed us to stay flexible, and allowed me to use R, Python, or whatever I wanted. So our pipeline today looks a bit like this, very high level, right? We can dig deeper later. If you have any questions, we can show you other charts, but this is the main idea. We have a DVC pipeline, which I'll talk about later, that simply works with two commands, right? We change some code, DVC repo, DVC push, and we have a brand new model trained. We then open a pull request in GitHub where we are able to code review any changes and check metrics with CML. When we merge this pull request to master, we have a Jenkins job that checks out the models directory from our main repository and does a couple of tasks, mainly pushing to S3, updating DynamoDB. All of these things are necessary because we use SageMaker to deploy our models. And this is also an open source project that I wrote. It's a SageMaker server in R. So you can use it to deploy right now just XGBoost, but check it out and let's collaborate if you need any other type of model. So it more or less looks like this, right? We go from a DVC pipeline to a real-time inference model. Everything is written in R except the deployment scripts, which are Python. And the whole process, takes like 40 minutes or so if you're training a model from scratch, which I think is really nice. Today, we're only focusing on this specific bits, only the DVC pipeline. So if you don't know what Jenkins is or SageMaker, it's okay. Although I can also explain that later if you're interested. So looking into our DVC pipeline, it's 99% R code, although we also have a stage in Clojure because neither R nor Python was fast enough to parse a couple 100,000 PDFs to extract data, and Clojure does this in a couple minutes. And this is, again, another reason why we like DVC so much, because why should I use a language that is not meant for something like this? DVC just lets me create a new state and go with it. Otherwise, our pipeline looks very standard, in my opinion, for what is a machine learning workflow. We read data from raw sources, such as databases or Excel files we get from external data providers. We have to clean this data, put it in the correct shape, train and tune our models. We use the tidy models framework, and then export artifacts and plots and so on. So it's not atypical, I think. What is maybe a bit different, at least I haven't seen anyone doing it like this, is that we define our models in just a YAML file configuration. and we just go through it one by one. It's actually one of the first things I asked when I talked to Dimitri back in the day about DVC was like, hey, can we loop in a configuration so we can have multiple models? And so from now on, I'll show you some code of how all of this is put together, starting with the beginning for me, which is the models YAML file. So everything begins in this file. Whenever we want to add a new model, we usually just need to add a new block like this. I hope you are seeing my cursor, so you know what I'm pointing. Or I can also try.
Yeah, now we can see your cursor.
This. Okay, good. So
we can also see the angle.
Perfect. So, so this block defines one model. There are more features or variables in our production set, but this would be too long, right, to show here. This endpoint part is just necessary for the deployment because our API has multiple models. And this is just telling that Jenkins job, look, this is going to be used in the fraud API. So put everything there. All of these aliases and names are used to create a directory inside our repository so that both data and artifacts, so everything that we get from a database, and then everything we export from the pipeline, such as plots, metrics, or a model file, are all separated into specific folders. So you can always know exactly where each model is. Taking this, we then can create something that looks a bit like this stage in DVC. So this is just a cut from our actual production DVC YAML. We load up this file, this models YAML file, so that we get access to all of these variables in the models. And then we use for each to go through one by one in each of the stages. In this stage, for example, we are just getting some extra fraud cases that need a different query. You can see we are using a script that we save in the stages directory. This will make a bit more sense later when I explain how dvthis works. For now, just think that all the stages are our scripts. They all live inside the stages directory, and they can get different arguments. In this case, we are giving it a SQL query, which is parameterized. So it only fetches data for a certain merchant and data from a certain point in time. So just by looking at this, I immediately know, okay, company ABC uses data from this data set, and that's usually more than enough to explain to someone what's the population that we are using to train a model. And then, you know, the typical DVC stuff. The more interesting bit here, I guess, is this. You can see that we are creating directories based on the models that I'm using. Again, this is a bit specific to my use case. It's not something that you need to do, I guess. You can just have a single model being trained, but it shows how flexible things can get and how you can train a lot of models in one go instead of having multiple scattered around pipelines. And so working and doing all of this stuff, I came up with a couple of best practices. And again, these are my best practices. They are by no means something that is written in stone. Some of these things are written already in the dvthis documentation. And it's something I told Jennifer before in our conversation, I felt was missing a bit in the DVC documentation or in conversations in general, because the docs are good to start technically. But then things like this, for example, you don't need to number the stages, right? Because DVC will create the DAG for you. This seems obvious, but lots of my colleagues were doing this anyways. And it was just creating some confusion. So I made a couple of rules. For me, the most important ones are just this first one and the last one, by saying that all the files that are saved to disk that are not to be used by a stage immediately, except for the raw data, all have the same type, all have the same data type, right? So if I'm saving, for me, for example, I'm using QS. I guess some people in R would rather use RDS or just a CSV file, but I try to keep things as constant as possible so that whenever I'm opening a new stage for a new step, for example, I know that all the data that comes beforehand is saved exactly in the same format. So I don't need to think what's the what's the file extension, and this then plays really well with the dvthis functions that I will show you. So we've been talking about dvthis, but what is dvthis? Dvthis is a package I wrote to accelerate a couple of these steps. I guess the big thing right now is that you can create an RStudio project much quicker. You just create a new project like you would any other, use the dvthis template, and you will get a project already ready to go with DVC and Git initialized, already with the DVC YAML and an example stage. Then just some functions so you can add new DVC stages and read the intermediate data, which is always saved to the same place, and also save intermediate data, which makes things consistent so every stage looks exactly the same. I'm still looking for ideas. I'm using this pretty much by myself right now. So do use it, check it out, and tell me if you have any ideas. So I think it would be cool to show you how this works in practice. I have some code here. And this is an example, very contrived, of using dvthis. So you would use the add R stage function from dvthis to create a new stage. In this case, I just call it hello world. And you would get pretty much these things already set up for you. So you get a nice header, which prints really nicely to the console. I prefer to see colors instead of just blanks. And you get a footer to tell you that things are done. So this stage is finished. And when you are scrolling and checking if everything is okay, you get a nice output. Then there's also some functions to log the stages, just called log stage step. And again, this just logs, just prints like message in R, but looks a bit nicer, creates a little bullet point, just a couple of niceties. And finally, what is pretty much the workhorse of dvthis are the save and read intermediate result functions, which in this case takes an R object. And if you don't say anything else, it will right now just write to the intermediate folder with this file name and no extension using the QS package. If you want to use something else, you can do it like this. So you can create a relative path relative to the intermediate directory, and you just pass in any function you want as a serializer. In this case, I'm saving the file as RDS. So with these few functions, you kind of bind all those R scripts together very easily without having to think, what file did I use before or so on. And DVC will just capture all of these things very easily. Cool. So we have a little demo now of creating a new project. So all of these things together. You would just create a new project like you would normally. You just choose the DVC pipeline template. Give it a very specific name so you know what you're doing. Create project. Can already see some output here. We are done. And now the interesting stuff happens. You already have a DVC YAML ready to go. So you can start adding stages there. And the file structure is also ready. So you can see you have metrics folders, reports folders, stages folders, and inside you have all your stage scripts. And here you see in pretty much the same as I showed you before, just without this custom saving function. You also get an add-in to just run DVC repro. And here you can see the nice printing. So we never need to leave RStudio anymore or switch to the console. You can simply go to the add-in. I haven't done that yet, but you can bind this to a keyboard shortcut. So you can just get DVC reproing whenever you make a change. Now you can see the save intermediate result will always save the data in the data/intermediate folder. So you can see that the random numbers file is right there. And now I'll just show you quickly how to add a new R stage. So you just need to give it a name. You can also set which dependencies and outputs you want. So it adds everything to the DVC YAML file. And here it is. You already have a new file open. So if we go back to the stages directory, you see there's a new script, which is right here. And the DVC YAML will now have the command ready to go. The dependencies already set for that R script. So now if you just run DVC repro, it's not doing anything, but it's already working, right? I'll just want to show you how this works. Give me just a second. Yeah. So what I didn't show you was the read function. And this is really my favorite because you don't need to think at all. You just need to say read intermediate result, random numbers, and then you get the data. So if you follow all of these steps and be consistent, you never really need to know where the data is, what name you gave it in terms of extensions. So just remember, I need random numbers. That's something from stage before. You just load it with the read intermediate results. Then if you want to save, the models in the end or do metrics or plots, then you have to do it on your own. I don't have a function for that right now. But it's something we can think about adding if people want that. And with that, I'm actually finished with my demo and what I wanted to show you so far. I will gladly take any questions regarding any step of this. And you can find me at my personal websites, GitHub, Twitter. If you have ideas, I will take PRs and any comments. Thank you very much.
Thank you so much, Santiago. And we do have a question from Marcel. Marcel, do you want to turn on your mic and you can just ask the question here?
Sure. So my question is it possible to have several different stages in the same file by using the stage header and stage footer of your package?
I think the issue there is DVC will not run it as different stages because you need to run a single command. I guess you could do that if you had some arguments, but then it kind of defeats the purpose. You know, if you have a script that takes an argument and chooses which parts to run, but that's really not the idea. So this works better if you have very small stages that do a single thing. For example, what I showed you, the example I had here is get DB data. And this script does only that. It only connects to a database using a SQL query and dumps data. It doesn't clean it. It doesn't change it. It doesn't do anything. So our DVC YAML is pretty big, but then you can know exactly what each stage is doing without having to look into it.
I see. Thank you.
Any more questions?
You mentioned that you made your own model serving kind of package or something.
Yes.
Is that just because you didn't find any that suited your needs? Is that because you were using R?
Yeah. So AWS has only servers for Python. Everything is Python related.
Sure.
And you could serve XGBoost models in their server, but then you cannot really do anything else. And what we actually have, I can quickly show you how our architecture looks like. It looks kind of like this. So we actually have two pre-processing images in a pipeline. So whenever we get a request, it goes through an API gateway, a Lambda that dispatches to SageMaker. And then inside SageMaker, we have a pre-processing container that has a recipe. Everything is R, right? So the recipe processes the data and sends it to the inference container, and then we get everything back. So yeah, so I had to make my own. And it was a bit tricky because documentation for AWS for this stuff is kind of weird. Like I asked some engineers from AWS how some things worked, and they were like, "You want to do what?" No, but
it seems like a lot of effort. Yeah, sure.
Yeah, but it's done. So and it works really nicely.
And what is the full list of functions that you have with this package? You show like how to get intermediate result, and maybe like can you like provide a list of like functions or?
Well, it's not a lot right now because this is kind of what I use. But you can add the stage, you can repro, you can log, and then you have the read-write functions in stage. So pretty much what I showed you. Right now, we don't have anything else, mostly because I haven't found the need. But I will gladly add anything else. And also, if there's a better way to integrate with DVC besides running things in the terminal, right? I'm just dispatching DVC to a terminal via R and opening it in RStudio. It's nice, but it's not the same as full integration where you can just have it pop up in the R console. So if at some point, or if it already exists some API from DVC itself that can be plugged into, then I will also create functions for that so that you never need to leave RStudio.
And for example, add stage, what would be the use case for using add stage function?
So I think here, from reading the documentation, I feel I work a bit differently from what you guys were expecting. So I'm usually going stage by stage. I write my code first. I try to figure out from the data I had from a previous stage if things are working. And if it is, then I will do DVC repro. So in that sense, if I already have, say, the stage for getting the raw data, I will now add a new stage to clean it. So I first add our stage, clean data, and I start working on it. And only then will I do DVC repro and I keep going, right? So I prefer to add stages like this than to, I don't know, add the data first and then the code. So I prefer to code first. Maybe it's specific to my way of working, I don't know, but again, we can still change lots of these things.
And how many stages you have in your pipeline?
How many stages? Let me quickly check. It's a lot.
It looks like a lot.
I think we have around 15 or so.
Is that 15 including all of the for eaches expanded or?
No.
Nice.
Yeah, so right now, so our YAML file, our DVC YAML is 400 lines of code. I think it's like 15, 16 stages. So we are getting lots of data from multiple places, splitting, cleaning, and so on. And then this is further expanded by all of the models that we are training. Like so far, it's only 5. It's not so many, but that's already interesting that we can just like with the single command, I can add a new model that takes 9 lines of code. Right before we had to change a lot of things. Right now, I just add 9 lines of YAML, DVC repro, and it's ready to go in deployment, in production.
Cool, really cool. And especially it's cool because it's R, it's not Python.
Yeah, I don't know what people are so against deploying Python to R to production. Like I definitely wouldn't, I don't think we will have this forever because as the company grows, we will start having more extreme loads on our servers and then R just cannot cope, right? That's just how it is. But then I wouldn't do Python either, right? You need to go to something like Clojure, Scala, Java, something that's a bit more powerful. But for our size, it's perfect because I can work by myself. I don't need another team to redeploy my stuff. I go from idea to production, all in the same language without cognitive load or having to wait for someone else to do work for me. And I just hope more people are able to be empowered to do this too, instead of waiting for someone else to kind of translate their cool R models.
Yep. Yeah. No, I mean the language is great. I like R. I use R in some project, especially when you work with data frames. It's just so nice working with the data frames. And for us, from DVC developer's point of view, R is not the most common use case, but it's great to see that some people use like not only Python but some other languages.
Yeah, totally.
Yeah. And Marcel is R user, right? Marcel.
Yeah, I work with R. And actually what we do is that in our platform, we do have things that take a while, like some tasks that are very CPU intensive. And what we do is to wrap some C++ code into our packages or our tasks. So in the end, we can use R, and if we need performance, we use the C++.
Mm-hmm.
I mean, isn't that the joke that between R and Python is just a way to choose what's the best API to use C++?
Yeah, probably.
Exactly it. Yes.
Thank you so much, Santiago. That was awesome. And I think very helpful to all the R users, and it'll be great. I've shared the link to the repository in the chat, so you can all check that out.